Okay, so let's take a look at advanced classes. So let's start with a review. As I was just mentioning to you a little bit about your prior to learning. So the dictionary defines the word class as a number of things regarding as forming as a group by reason or common attributes, characteristics, qualities, or traits. It also is related to the word classify and the word classification. So right in the dictionary definition, you can see the relationship there. So we classify things by their attributes, which is properties. We can also classify things by their behaviors or traits, which is methods. So we classify things in that way. But the simple definition I gave you last year was that a class is a collection of properties and methods. And if you think of it in a real world example, it isn't that difficult of a concept. So let's break it down further. So if we're talking about properties and methods, what we're talking about are these things about the class. Now what happens is a class becomes an object. You use one class to create multiple objects. An analogy I gave last year was a class is like a cookie cutter, and the objects are all the cookies that you make from it. Or if we were architects and builders, I could give you one blueprint for a house. That's the class, the blueprint. And you could use it to build many houses in a neighborhood. All look the same, but they'd all be objects of that class. Properties describe the object. They're things about it. Okay, so they're descriptors. Methods are actions or things the object can do. So they are the two parts of an object or a class, the things it can do and the things about it. If we were in English class right now, what words could we use to describe these things? What in English are words that are actions? What's a word for that in English? Verbs, yeah. Verbs are actions. What are words to describe something? Adjectives. So then what would the class be? What do adjectives describe? Nouns, right. So a class is a noun, properties are adjectives, methods are verbs. That's another way you can think about it. I don't care which analogy works for you as long as you are understanding what a class is, because now we're going to go into more advanced details on this. Okay, does everyone feel okay with the concept of classes? Let's move on. Okay, we also then looked at this concept of a superclass. So you may remember that. How does that relate? Well, a superclass is a relationship between classes. Okay? There are two different ways classes can relate to one another. One is through the superclass subclass, or known as inheritance. Okay? With inheritance, we have a child class and a parent class, or what is simply put, the is-a relationship. So you may remember that last year we made a class called person, and then we made a class called student, and a student is a person, right? So that's the relationship known as inheritance, where one class, like in biology, inherits all the properties and methods from the other class. The class being inherited from is the superclass and the parent class. In C#, they call it the base class. Okay? The class doing the inheritance is called the subclass or the child class, and that's the is-a relationship. The other type of relationship between classes is simpler. It's just known as composition or association, where one class is composed of another class or associates with it. With this, it's the has-a relationship. So in that one, what you can do is you can have a class, and one of the properties of the class is another class. So that means they're not related through inheritance, they're just associating with one another, or they're composed of one another. Okay, we'll see that in the example. So let's start with this. Okay, let's start with recreating a simpler version of our person class. Okay, so everybody start up NetBeans, and we're going to use the big example that we've been working on when we put in recursion. So we're going to start by adding a package for classes, for testing, and we're going to put all our classes into that package. Okay? Okay, so here's what we make. We made, just to review again, we made a advanced classes package inside of the testing package, and we made two classes, advanced classes test and the person class. They are inside of the package we just made. Okay, let's start with the advanced classes test. All we need to write in this is a constructor. So public advanced classes test. So when we bring up the advanced classes test, it'll run whatever code we want to put there. Okay, so let's just make sure we have the constructor in place there. Advanced classes test. Now we jump over to the person class. And let's quickly write some code for our person class. In the person class, we're going to keep a very simple person object here. So our person will have a name, so string name, and an age, int age. Those are two properties of the class. Now, let's use encapsulation, the idea that we can hide and show properties and methods. Let's use both of them. So the name will be private, private name, and the age will be public. Okay? So name is encapsulated, right? It is hidden from outside the class. You can't see or access the name because we've made it private. That's just as a review of what you can do. I'm not saying we should have done that. I'm just saying that's what we can do. Whereas age is public. You can see it outside the class. Okay. Now, let's write our constructor method for this person class. So just as a review, I know we just wrote one in the other class, but a constructor method is a method with the same name as the class. So they have the exact same name. It has no return type, not even the word void. If you put the word void in there, it is no longer a valid constructor. It thinks it's a regular old method. Constructor methods are called when you build an object. Okay? So let's set a name equals, I don't know, John Doe. It's just a generic person, and their age equals 0. So when we construct a person, that's what we're going to set with their properties. Again, this should be a bit of a review. And then finally, let's just give it one method, a public void talk method. And all the talk method does is it outputs that their name is age. So it'll say, like John Doe is 0 when they talk. Thank you. Okay, so that's it. That's all we're putting into this class. It's a very simple person class as a review. Okay? So this was our default constructor. Does anyone remember why it's called the default constructor?
Yes.
Why?
Because you have no parameters.
Right. A constructor without parameters is called a default constructor. Okay? You can overload that, another word you should be familiar with a second constructor if necessary. But we're keeping this simple. This is just used to output information. That's all the talk method does. It outputs information. Okay? So here's our person class. A person with a name and an age. The name is encapsulated. That's where the concept comes from. Like putting pills inside another pill, like space rangers? What are they called now? Astronauts, that's the word I was looking for. Astronauts inside of the capsule. And their age is public, so we can change their age. Okay. Now let's use our advanced classes test to build an object, to build a person. Okay, what should we call this person? No, but not yet. Not yet. Too early. Just a generic person. Person? Okay, person equals new person. And then person dot. We can now access the talk method, and we can access their age. Notice name is private. We can't access that. So let's just have them talk. Let's call that method. Okay? So we create a person. Here we are creating an object. What's a better word than creating from our vocabulary list? Right. Instantiating an object. Very good. Now, we need to run this test, the advanced classes test. So we also need to go to our tester class. Oops, not that one. So go to your project, find your tester class. And notice, in tester, we're still running our recursion test. So let's follow that up with a advanced classes test. Which I'm just going to call Unit 2. Equals a new advanced classes test. This will need to be imported because it's coming from a different package. It will either do it automatically for you or the light bulb will suggest that it needs to be imported. Now again, it needs to be imported because it's coming from a different package. It's still your project, but it's a different package. Now, I don't need to run my recursion test anymore, so I'm just going to go to the front of that line and comment it out. I just don't need it. So now I'm going to run the tester, which will run the advanced classes test, which will create a person and then ask that person to talk. That's what should happen. And sure enough, that's what did happen. The person talked. John Doe is 0. So that worked. That did what I expected it to do. Okay? Let's do one other thing. Before we have it talk, let's say person.age equals 17. So that is a public property, so I can change it. And sure enough, the change is reflected. Okay? So now the output comes out that their age is 17 when they talk. Okay? All right, so that's the basics. Everybody good with that? All right, now let's add another class to our project, a new Java class called student. Okay, so now you should have a student class in there along with the person class. So we have person and student. This again is a bit of a review from last year. All right. So the first thing we're going to do with the student class is we're going to initiate inheritance. The is-a relationship. We're going to have the student become a person. Who remembers the Java keyword that's used to initiate inheritance? It's not is-a.
Oh, extends.
Extends, right. So student extends person. This initiates inheritance, which means instead of the word extends, you can think of it as the word is-a. So a student is a person means all the properties and all the methods are now shared with this class. So it gets all the same properties and methods, and we can add to them. Okay, so it avoids you having to rewrite all that code. So that's inheritance. In C#, it doesn't use the keyword extends. It uses a colon as the symbol to initiate inheritance, but that's neither here nor there. Okay, so now we're going to add a property to the student class. It will be a private property. In other words, it's encapsulated. It's an integer for their student number. Okay, so a student has a student number. And then let's write a constructor method, public student. And we're going to avoid the default constructor by giving it parameters. Here's what we're going to do. We're going to give it a name and a student number. Now there's a potential conflict here. Well, hang on, let me show you the conflict. I use the exact same spelling right here for student number as I have in my properties. I have a parameter. This is a parameter. And this is a property. And they have the exact same spelling, the exact same wording. Should I have renamed one of them, or is there a way around this? Peter, pay attention. Everybody pay attention. I gave you a big clue in the way I just said that. There is a way around this? This dot. Yeah, you guys may remember that. Okay, so here's what we're going to do. We're going to set the student number right now. We're going to say this dot student number equals student number. Now again, this is a little more advanced, but what that line means is when I say this dot student number, it's referring to the class itself, specifically the object that will be created. So this is being used as a placeholder to say, well, when you create an object, the student number will be equal to that thing, which is the parameter. Okay? So it's taking the parameter and putting it into the property. This is so that it makes it exclusively correct in the sentence structure. If I did not put the word this there, if I did it like that, notice how NetBeans gets confused by this. It doesn't know what you mean. The light bulb will actually suggest the correct solution. Okay? Actually, no, it doesn't. It doesn't actually have a solution. It just thinks that the error is wrong, which it isn't. Okay? Now, how to get at the name? Because name is not a property of this class. Well, name is a property of the superclass. Super dots. But again, here's a bit of a problem. Name, if I do this, super.name equals name, it is, as identified here by the light bulb, name has private access. I can't change it. It's been encapsulated. Okay. Well, let's fix that. We can fix it in lots of different ways. But the way we're going to do it is a unique way. We're going to go back to our person class, and I'm going to teach you a new concept right now. There is a level of visibility or encapsulation in between public and private. So it's in between. And it has a different keyword, which is what we're going to switch this to. And the word is protected, which we're going to talk more about in a second. So I want you to change your person class that the name is now the word protected. Okay, we're going to talk about that in a second. This is a new concept coming out here. Okay, that should fix your error. Notice now super.name equals name. Okay, now we're going to write a method in our student class. We're going to write the talk method. Now, just a second. We already have a talk method. What is this called? Think before you answer. When you have a method for which you already have that same method, but this method is in a different class, specifically a child class or a subclass. What is it called, what we're doing with the methods here, Peter? Overriding, not overloading. We're overriding the method. And here's how we're going to talk. First, we're going to do this, super.talk. So it first calls the talk method of the superclass, which jumps to person and runs this code. But then we're going to output something else after that. We're going to S out student number plus student number. So we'll then output the student number. So when a student talks, they will output the same information as a person, but then add to that their student number. And that's what inheritance is for. You take an existing class and you're adding content to it. Again, that's just a bit of a review from the 30S course. Now, let's go over to our tester, the advanced classes test, and let's make a student. What should we call this student? You think so? How about just student, student? Student, student equals new student. But let's give this student an actual name. No, I don't want to use you guys yet. We're going to get to that. The most generic student name you can think of. How about student D? Mixed students. McStudentson. Student D McStudentson, who is 17. No, this is not supposed to be their age. This is their student number. So this will be student 101 or 1001. And then we'll have that student talk. So student D McStudentson, whose student number 1001, will now talk. Let's see what happens. Run that. And there it is. Student D McStudentson is 0, because we haven't adjusted the age, and their student number is displayed. That's good. Let's slip in one more line of code. Student.age equals 16, 17 if you want, and we'll play it. And now that has also been changed. Okay? All right. In a lot of ways, this is a review of everything you already know. You know all of this. Except for one new piece of information, the word protected. We will pick up on that tomorrow and add new stuff to the classes we have. I have to be done with you guys now, for now.